Hello, hi everyone. In this video, we are going to see few more problems of the polynomials. Let's begin with the small topic, relation between zeros and coefficient of a polynomial, which help you to solve the exercise 3.3 questions. So we heard about the zeros of the polynomial in the previous video, right? And the coefficients are nothing but coefficient means those are the constants before the variable. For example, here, if you take this polynomial x square, 2x square, in this x square coefficient is 2, minus 8x, x coefficient is minus 8. Okay, and 6 is a constant. Okay, this. So when you compare with the standard form of the quadratic polynomial ax square plus bx plus c, in that a, b, c are called constants. I'm sorry. A, B, C are called as a coefficients. Okay. So now we will see the relation. See here. In general, if alpha and beta are the zeros of the quadratic polynomial, this is the quadratic polynomial where a should not be equal to 0 if alpha and beta, two zeros. Because this is a quadratic, since the degree is 2, we will get the two zeros or two factors. Okay, so then the factors are x minus alpha and x minus beta. These becomes the factors. If 2 and 3 are the two zeros, then x minus 2 and x minus 3 will become the factors. So simple. Okay, then even when you know the zeros of the polynomial, even you can frame a polynomial. When you know simply the zeros of the polynomial, you can find out the polynomial. What is the polynomial by using this relation? That is equal to, polynomial is k times of x square minus alpha plus beta times of x plus alpha beta. Here you can put alpha plus beta value. Here you can put alpha into beta. You can multiply and put, so that you will get the polynomial, the required polynomial by using the zeros of the polynomial. In the same way, we can also find out sum of the zeros. See here we considered alpha and beta are the zeros. So sum of the zeros formula, when you know the quadratic polynomial, then the sum of the zeros is minus b by a. This is the relation. Alpha and beta are the zeros, and b and a are the coefficients of the polynomial. So alpha plus beta is equal to minus b by a. Minus b means what? Minus of coefficient of x divided by coefficient of x square. If you do, you will get alpha plus beta value. In the same way, product of the zeros of the quadratic polynomial. Product means multiplication. Zeros are alpha and beta. So alpha and beta, if you want to find out, the formula is c by a. C means it's a constant from the standard form by coefficient of x square. Means that is a, c by a. Okay, we need to remember these two, sum of the zeros and product of the zeros. Next, one more thing. For the cubic polynomial also we will see at a time. Cubic polynomial means it's having a degree 3. So cubic polynomial will have at most 3 zeros and 3 factors, isn't it? So now see the important relation between the zeros and coefficients. See, ax cube plus bx square plus cx plus d is a cubic polynomial with 3 zeros, alpha, beta, and gamma. Okay. Here, what are the coefficients? A, B, C, D. Okay. Then x minus alpha, x minus beta, x minus gamma will become the factors, right? So if you know the alpha, beta, gamma values, you want to find out the polynomial. You want to write a polynomial for those zeros. Then the formula is x cube minus x square times of alpha plus beta plus gamma plus x times of alpha beta plus beta gamma plus alpha gamma minus alpha beta gamma. సో చాలా లెందీగా ఉంది అని కంగారు పడొద్దు. By practicing more number of questions, you will get it very easily. Okay. So let's see the sum of the zeros. Alpha plus beta plus gamma is equal to minus b by a. These are the zeros and this is the coefficients. So this is the relation. When you are adding 3 zeros, the relation is minus b by a. X square minus of x square coefficient by x cube coefficient. Next, if you want to find out this alpha beta plus beta gamma plus alpha gamma, then c by a. C by a. Okay. X coefficient divided by x cube coefficient. And if you want to find out the products of the zeros, alpha, beta, gamma, then minus d by a. Negative of constant term by x cube coefficient. Okay. So we are going to use all these things for solving exercise 3.3 questions. Let us discuss exercise 3.3 questions. Here it is. Find the zeros of the following quadratic polynomials. We need to find out the zeros first and verify the relationship between the zeros and coefficients. Then sum of the zeros and product of the zeros relation we need to check. Remember, children, if you want to find out zeros of the polynomial, take the given polynomial and put equal to the zero for finding. జీరోస్ ఆఫ్ ద పాలినామియల్ ఫైండ్ అవుట్ చేయాలంటే ఆ పాలినామియల్ తీసుకుని ఈక్వల్ టు జీరో చేసి ఫ్యాక్టర్స్ ఫైండ్ అవుట్ చేసి జీరోస్ రాయాలి. ఓకే, సో లెట్ us put it on the board. The question number 1, given one polynomial, let us take it as a p of x is equal to x square minus 2x minus 8. This is the polynomial given. You need to find out the zeros of the polynomial. So to get the zeros, put p of x is equal to 0. So x square minus 2x minus 8 equal to 0. By splitting the middle term we can do. What are the factors of 8? 1 8 is 8, 2 4 is 8, 3 doesn't go, 4 came off. So now these two, if you see, we can split the middle term by these two factors. 2 plus 4 gives 6 by 1, but we want a minus 2 here. So let's put minus 4 plus 2. Minus 4 plus 2, if you add, you will get minus 2, isn't it? But plus into minus gives minus 2 4 is 8, which is minus 8. When you multiply these two factors, you should get a constant. When you add these two factors, you should get a middle term. So this is satisfying. Let's take these two are the considerable factors. So x square, this can be split it as plus 2x minus 4x minus 8 equal to 0. In first two terms, I can see x is a common. So 1x will be remains plus x already gone out, 2 will remains. In these two terms, minus 4 is common because 8 is also 8 has a factor of 4. So minus 4 gone out means x remains. Already minus we took it as a common, so plus remains. 4 divides 8 2 times. One observation must required here. These two should be same, otherwise your answer is wrong. So these two common, these two will be taken as once again common, and the remaining constant or a variable should be written as a together as a one factor. Okay, so x plus 2 equal to 0 if we put, what is the x value? Minus 2. Or x minus 4 equal to 0 we put, x value is plus 4. So zeros of the polynomial, therefore zeros of p of x is equal to minus 2 and 4. So we already know alpha and beta are the zeros of the polynomial. So alpha value is minus 2 here, beta is a 4. To compare, to verify zeros and the coefficients, we need to compare our polynomial with the standard form. So let's compare p of x with the standard form, ax square plus bx plus c. Okay, where a should not be equal to 0. Okay, what is a p of x? X square minus 2x minus 8. Okay, so x square minus 2x minus 8, and this is. So what is a when you are comparing? A value is 1 in front of x square coefficient. Next, plus b value, x coefficient, b value is. So here x coefficient is -2. C value means constant. Here constant is -8. Okay. We know the sum of the zeros. Sum of the zeros formula. Sum of the zeros of quadratic polynomial is alpha plus beta. And we have the relation minus b by a. Alpha plus beta means what did we get as the zeros? -2 plus beta value is a 4 is equal to minus b by a. Minus of b value is -2 divided by a value is 1. So -2 plus 4, unlike symbol, subtracted. So answer is 2. Greater number sign follows. So +2 is equal to minus into minus +2. So both are equal. So our zeros are correct. So this is the relation. Next see. Verify the relation. Verified. Product of the zeros. Alpha beta is equal to C by A. Alpha value we know -2. Beta value 4. C value is -8. A value is 1. Now minus into plus minus 2 fours are 8, which is equal to -8 by 1 is nothing but -8. So product of the zeros are same with the sum of the zeros. Hence it's verified. Verified. Like that, we can solve remaining sums. Let's see one more question. 4s square minus 4s plus 1. Second bit. 4s square minus 4s plus 1. So multiply s square coefficient and the constant. 4 ones are 4. We need to write the factors for the 4. 1 4 is a 4. 2 2 is a 4. That's it. So we need to get a -4. So if I put -2 can be added as a -4. Minus into minus plus 2 2s are 4. When we multiply these two factors, it is satisfying this. And when we add, it is satisfying the middle term. So let's split the middle term with these two factors. 4x square minus 2s minus 2s. This is a minus 4s plus 1. In these first two terms, I can take common as a 2s because 4 is a factor of 4 has a factor of 2. 4 has a factor 2. So 2 2s are 4. 1s gone means 1s remains. 2s is out means nothing is left. So you take it as a 1 because 2s into 2s 4s square. 2s times of 1 is 2s. So it's satisfying. Now here nothing is common in these two terms. Let's take it as a -1 common. Okay. Now 2s will be left. We should not take positive 1 as a common because in the brackets we should get positive 2s minus 1. So let's put the negative symbol outside only. 2s already when we are multiplying with the minus, minus into plus is minus and 1. So these two should be written only one time and remaining numbers and variables can be write it as a one factor. Sorry. Let's put equal to the 0 for finding the zeros of the polynomial. Okay. So now 2s minus 1 equal to 0. 2s minus 1 equal to 0. So s is equal to 1 by 2. Here also same. S is equal to 1 by 2. Okay. So these are the zeros of the polynomial. We need to verify the relation. Now, let's compare this. Let's compare the given polynomial 4s square minus 4s plus 1 with quadratic standard form ax square plus bx plus c. So here a value is a 4, b value is a -4, c value is 1. Then sum of the zeros. Sum of the zeros is alpha plus beta. Alpha plus beta formula is minus b by a. Alpha value is half here. And beta value is also half. So half plus half, 1. And minus of minus 4 by a value is 4. Half plus half is 1. No need to do LCM. Otherwise, you can do the LCM also. 4 get cancelled. Minus into minus plus 1 remains. Right? Sum of the zeros verified. Let's verify the product of the zeros. Product of alpha beta, which is a C by A. Alpha beta is 1 by 2 into 1 by 2. C by A means 1 by 4. So 1 by 2 into 1 by 2 is 1 by 4. 1 by 4 is equal to 1 by 4. LHS equal to RHS verified. Both coefficients and zeros are verified. Now let's see the third bit. Third bit. 6x square minus 3 minus 7x. 6x square minus 3 minus 7x. Minus 3 minus 7x. See, this polynomial is looking different. It is not like a standard form. You need to do the rearrangement here. Okay, let p of x is equal to 6x square. Next is a x term should be there. So just write this one minus 7x, then minus 3. For finding zeros, for zeros, put p of x is equal to 0. That means take this polynomial and equal to the 0. Okay. Now multiply x square coefficient and constant. Plus into minus minus. 6 3 is 18. 18x square we need to write the factors. 1 into 18. 2 9s are 18. 3 6 are 18. 4 doesn't go. 5 doesn't go. 6 already came off. Now which two factors if we add we will get the middle term. Let's see. 9 minus 2, 7 we are getting. Adding or subtracting, right? So, but it is a minus 7 answer. So, big number will have a minus, small number will have a plus. Minus 9 plus 2 gives minus 7. And plus into minus minus, 2 9s are 18. Yes, these are satisfying. Let's split the middle term in this way. 6x square plus 2x minus 9x minus 3 equal to 0. Instead of middle term, you have to write it. So in these two, what is a common? 2x is a common because for 6 and 2, 2 is the HCF. 2 divides the 6 3 times. 1x gone means 1x remains. And 2x already gone out, so 1 remains. Minus here, 3 is the HCF. Take 3 as a common for 9 and 3. 3 3 is a 9. And x minus already came out common means plus 1. Minus into minus is plus 1. So these two written as a one time and these two can be written as a one factor. So now if we put 3x plus 1 equal to 0 and 2x minus 3 equal to 0, let's find out x value. 3x is equal to minus 1, x is equal to minus 1 by 3. Same in the same way, 2x is equal to 3, x is equal to 3 by 2. So what is alpha? Here alpha is equal to minus 1 by 3 and beta is equal to 3 by 2. Let's compare the polynomial with the standard form. Okay, compare p of x with we'll take a polynomial only. Written polynomial. 6x square minus 7x minus 3 with ax square minus ax square plus bx plus c. Here A value is 6 when you are comparing. B value is -7. C value is 3. Let's verify the zeros and the coefficients. Sum of the zeros. Alpha plus beta is equal to alpha plus beta is equal to minus b by a. Alpha value is -1 by 3 plus beta value is 3 by 2 minus of b value is -7. A value is 6. Two unlike fractions, take LCM before adding. 3 2s are 6. 6 is the LCM. This 3 divides 6 2 times. So multiply this fraction with 2. 2 divides 6 3 times. Multiply this fraction numerator with 3. So -1 into 2 is -2. Plus 3 3s are 9. Then that is equal to minus into minus plus 7 by 6. 9 minus 2 gives 7 by 6, which is same as a 7 by 6 RHS. Next, let's do the product of the zeros. Product is alpha beta is equal to C by A. Alpha beta are minus 1 by 3, 3 by 2. Next, C by A. C by A means from this 3 by 6. 3 1s are 3 2s are. So minus into plus minus into only na you can multiply even unlike fractions. 3 1s are 3 numerator multiply denominator 3 2s are 6. So 3 1s are 3 3 2s are 6 and 1 by 2. Okay. C by A. C value is -3. I'm sorry. Because constant is here -3, we will get C value here also minus 1 by 2. See, LHS is equal to RHS. You should get the same answer. Then we can say zeros are verified. Zeros are sum of the zeros and product of the zeros are equal to the coefficients. Okay. Next, fourth bit. What is the fourth bit? Let's see. 4u square plus 8u. 4u square plus 8u. For finding the zeros, let take p of x is equal to 4u square plus 8u. For zeros, for finding zeros, put p of x equal to 0. So 4u square plus 8u is equal to 0. In these two, 4u is a common. Then 4u gone means 1u left, and 4 divides 8 2 times and u already gone is equal to 0. These both are factors. 4u is equal to 0. U plus 2 equal to 0. So u is equal to 0 by 4 means 0. And u is equal to plus 2 means -2. So this is alpha and this is beta. Sum of the zeros. Before that, we will write what is A, what is B. When you compare this with the quadratic form. So A is 4, B is equal to 8. There is no constant term. Put a 0 in the question. In the question, they didn't give any constant term. So now, sum of zeros. Alpha plus beta is equal to -8 by 4. Alpha beta values are 0 and -2. 0 -2, which is -2. -2 equal to -2. Product of the zeros. Alpha beta is equal to C by A. Alpha and beta are 0 into -2. C means 0 by 4. So 0 into something is 0. 0 divided by 0 is something. So hence verified. Let's do remaining 2 bits also. Next, fifth bit. Let P is equal to P of X polynomial is equal to T square minus 15. So for finding zeros, P of X equal to 0. So T square minus 15 equal to 0. So T square is equal to plus 15. So if you want to find out T value, it's a square root of 15. When a square transposed to other side, it will become square root. Okay. So T values are plus or minus, no. So plus root 15 one value, minus root 15 another value. Now let's compare the given polynomial with the P of X standard form. Okay, here A is equal to T square means 1. B is equal to, there is no T term in the question. C is equal to minus 15. We should do the sum of the zeros. Sum of the zeros. Alpha plus beta is equal to minus B by A. My alpha root 15 minus root 15 beta is equal to minus B by A, 0 by anything. So this is 0 here and this is also 0. Okay, next to product. Minus 0 is nothing, 0. Product. Because there is no value for 0. Product of the zeros. Alpha beta is equal to C by A. Alpha and beta are root 15 into minus root 15 is equal to C value is minus 15. Okay. So minus root 15 whole square. Square and root get cancelled. So minus 15 equal to minus 15. Hence verified. Next. Last and final bit in this question, sixth one. Let P of X is equal to sixth bit. Sorry. 3x square minus x minus 4. It is in the order. 3x square minus x minus 4. Right? So, for finding zeros, put a P of X equal to 0. So 3x square minus x minus 4 equal to 0. Multiply the constant and coefficient of x square. Negative into positive, negative. 3 4s are 12. For that, 0 12s are 12. 2 6 are 12. 3 4s are 12. 5 doesn't go, 6 already came off. So we need to check which is a suitable pair of factors. 4 minus 3 gives a 1. So if we put here minus and plus, minus 4 plus 3 gives minus 1. Minus into plus gives minus 3, 4 is 12. So it is satisfying. 3x square plus 3x minus 4x. I simplified and wrote it as a 2 factors is equal to 4. In these two, 3x is a common, x plus 1. Minus 4 is a common, x plus 1. So x plus 1 into 3x minus 4 equal to 0. So x is equal to minus 1 or 4 by 3. So this is going to be your alpha and this is going to be your beta. Compare the polynomial. Which one compare? The question. 3x square minus 1x minus 4 with ax square plus bx plus c. So here A value will become coefficient of x square is 3, B value will become -1, C value will become -4. Take along with the sign, children, because in the standard form we have a plus everything. Okay, sum of the zeros. Alpha plus beta is equal to minus b by a. Alpha and beta values are -1 plus 4 by 3. Minus b by a, minus into -1, b value, a value is 3. So unlike fractions, take LCM 3. This goes 3 times. 3 ones are 3. Plus 4 is equal to minus into minus plus 1 by 3. So 4 minus 3 gives 1 by 3. 1 by 3 is equal to 1 by 3. Product of the zeros. So alpha beta is equal to C by A. So here alpha is -1 and beta is -4 by 3, which is equal to C by A. C value is -4 by 3. Minus into, yeah, yes, alpha and beta. Alpha value is -1 and beta value is +4 by 3. Minus into plus, -4 by 3. Here already we got -4 by 3. Both are equal, so hence verified. This is how we can solve when we know the concept. For more number of questions, keep watching my video children. Thank you.